So some of the problems with this process of picking out your actual population and sample is you may not actually know or want to know who needs to be generalized ahead of time. Um, so again, what is the want? What is the need? What is the population that's going to be most useful or need this information the most? And also, you may not be able to draw the ideal sample easily, and that's probably the biggest difference and or problem is that most research ends up using some form of convenient sample. Now, again, I think this is often going to be, that doesn't mean that you should just always use convenient samples and never think about this process. But I think the idea of true random sampling is a goal that we try to move closer to, recognizing that we may not be able to make it. And also, even when we do a true random sample, we do everything right, we get everyone that we wanted to in our study to where we can make a strong argument for generalization, we still can't sample across times or observations. So I have UTOS here, and that's often shorthand in external validity for unit, time, observation, and setting. So units, who's in your study, time, when you did your study, observations, how you did your study, and setting, where you did your study. So even if you got the same people in the same place to take your study multiple times, there's a good chance, one, that those observations may change, how you're actually gathering that information. In fact, you probably want to change the observations. And finally, no matter what, you can't not change the time. Time has passed. So even the most perfect study for external validity may still need to be checked later to see, do we still find these differences? Human behavior, human culture, what's acceptable behavior within a culture changes from generation to generation. So though we're striving towards the goal, we're also recognizing it may very well, in fact, it is an unattainable goal, but we do at least want to be, again, we want to be systematic. We want to think about these terms, and we want to at least be able to also discuss them in our discussion section. Who was our population, at least initially? Who do we think we want to generalize to? And what is the arguments we can make that it can generalize? So again, external validity, and this is just kind of a way to maybe visualize it mentally. The idea here is to generalize from our specific situation, our study, and the people studied within our study to the people that are not studied. That's really the definition of external validity. And again, our study, as you move away from our study, it becomes harder and harder to externally generalize. So as we go to different times, if a study has been on the books for years, it's probably less generalizable than it was when it was first published. If the study was done with 20-year-olds, it's probably less generalizable to 70-year-olds. If the study was done at Harvard, it's probably less generalizable to a small community college down in Texas. And likewise with the observations that we do. If the study was done with all self-report measures, it may be less generalizable to the actual behaviors that people participate in. So again, just a reminder of that structure of research is actually tying into these ideas of internal and external validity. So the hourglass notion of research basically suggests we start in the land of theory with broad questions. We review the research, we review past research and past articles, we do a lit review, and the idea is to focus down to our research question and based on past research, suggest an actual hypothesis. From that hypothesis, we design our study, we operationalize it into something that we have control over and we can gather information. That includes measurement, that includes methodology, and then we observe the data. Once we have that data from our methods, we then do our results. We analyze the data to reach conclusions. And that's where internal validity lives. Internal validity is within what we did. Can we trust the measures? Can we trust the manipulations? Did they represent the constructs that we're interested in? And if we find relationships, can we trust those relationships? If we do find internal validity, if we do find results, then in our discussion section, we make the argument that it would generalize from our question back to the theory or general human behavior. And that's external validity. Can we generalize what we found in the study to other people within the population that were not specifically studied in our study, at our time, in our place, and the way we studied it? So let's talk generally about the general types of research design, and this is the big one. It's basically, it can be broken up into two groups: experimental, which also includes quasi-experimental, and non-experimental designs. Experimental designs are when we're really trying to focus on laboratory experiments where we have taken everything under true control so we can make causal hypotheses and test those causal hypotheses. Quasi-experimentals kind of live between experiment and non-experimental design. Quasi-experimental design is generally when we're close to an experimental design, but there's still some issues. While a non-experimental design, we're not even making an argument for causation. We're simply looking for descriptive patterns. So what defines whether you're in a true experiment, a quasi-experiment, or a non-experimental design? The first one is random assignment into group, and the second one is whether or not you fully manipulated the IV. So usually if you have neither of these, there wasn't random assignment into conditions, and you were not manipulating or even really adjusting the IV, you're probably in a non-experimental design. If you clearly have both of these, you brought in a sample, you randomly determined which conditions they were exposed to of your IV, and you manipulated that IV through that random assignment, you're probably at a true experiment. So why is random assignment so important? Well, basically, it eliminates the individual differences of possible explanation for the results. Now, this is not an automatic process, but it's fairly solid. The idea here is that if you have a sample, and remember, I said that rule of thumb, we probably want 30 or more participants in any one study. One of the reasons for that kind of number is that generally when you get below 30, random assignment, it still works, but it tends to work less successfully. Because the idea behind random assignment is that if we took any group of 30 people and we picked out any particular thing we wanted to measure, let's say I'm going to just stick with what I keep using in class, extroversion. We're probably going to find that a small number, let's say 5, are extremely extroverted, a smaller number, about 5, are extremely introverted, and everyone else falls somewhere in that spectrum. Now, if I actually had to measure each person's extroversion and then assign them one person at a time, high extroversion, low extroversion, medium extroversion, to 2 different groups, am I also adjusting for their intelligence levels? Am I adjusting for their social economic status? So it's almost impossible, no matter how much you think and how much work you do, to try to measure and create 2 samples or 2 subsamples in one experiment to represent truly representational versions of that larger sample and therefore the larger population. However, if every person has the equal chance within my study, random assignment, to be in one condition or the other, most of those differences tend to average out because everyone, no matter what the variable is, 15 of them are randomly in one group and 15 of them are randomly in the other. And whatever that variable was, whether it was extroversion, cognitive ability, social economic status, you'll probably find a similar distribution that a few people that were low on it, a few people that were high, and most people in the middle are in both of your groups now because of random assignment. So some people would argue, well, why do I need random assignment? Why don't I just measure everything that matters? And again, it depends. This is just 2 factors, color and shape. So think of this as 2 factors, cognitive ability and extroversion, introversion. In this case, we could probably create 2 equal groups, 2 yellow circles in each group, 1 orange cross and 1 green cross and 1 orange pentagram in each group, and the 2 groups are now equal. There's an equal number of colors and an equal number of shapes in both groups. But unfortunately, human behavior isn't that simple. And even just one person being out of line messes things up. Now, no matter how I divide out this group, I'm not going to have necessarily the same number of conditions because I now have only 1 orange cross and 1 yellow cross. Those are different people that are not going to be represented in whichever other group they're in. So even one small change can start to create a problem. And again, when we talk about human behavior, we're looking something even more complex than this. It's going to be very hard to try to measure everything we're interested in and divide people up to where we can make an argument that the participants, at least, aren't what was causing the difference we find. Whenever we use a non-experimental design, when we let people choose which conditions they're going to go in, we may very well have what's called a confound, and that confound being the people themselves were different to begin with. Now, there's things we can do to try to address that and account for it. But the easiest way to not even have to worry about it is to use random assignment. And again, random assignment means that every person that's in your sample has an equal chance of ending up in any of the conditions that you're manipulating of your IV. So for instance, if your independent variable was an intervention of study guide or not study guide, every single person in your sample, let's say a class of 50, would have a 50-50 shot of randomly getting a study guide or not. And using that tool, you would have a much stronger argument of internal validity, that there isn't group differences to begin with. The only difference was whether they got the study guide or not. So why manipulate the IV? First, it eliminates those confounds. It does not eliminate all possible confounds, but it eliminates many confounds, and it mainly eliminates all of the possible explanations that could be because of your sample and how you divided people up. Now, again, random assignment works better the larger the groups are. So if you actually did divide people with random assignment and then measured any individual difference variable, if you've only got 10 people, and there's only one person in that entire group of 10 that is exceptional at whatever you're measuring, they're going to end up in one group or another. And it's going to cause some differences. So generally, that's one of the reasons we want to see a slightly larger number when we do experiments. But assuming we have a large enough number, random assignment almost always is successful at basically scattering all of those thousands of human differences and individual differences across our 2 groups, or 3 groups, or whatever our study is. So it eliminates a lot of those possible explanations. It also minimizes noise, extraneous variables that may influence our outcome, but are now evenly distributed across the experimental conditions. And the big advantage of both manipulating the IV and using random assignment is causation, causation, causation. If we know that we're manipulating the IV, we choose who's in condition 1, who's in condition 2 using random assignment. If we find a difference, it pretty much almost has to be that change that we caused. Now, if we're not manipulating the IV, for example, if I'm just comparing a class that always gets a study guide to a class that never gets a study guide, notice I don't have random assignment anymore. I have participants that have chosen one class over the other. One of those classes might be in the evening, and one of them might be at nighttime. They may even be different types of subject matters. It's going to be very hard to make a causal argument. I might still find a pattern. I might still find that students in the class with study guides does better, but that could also be because it's a morning class. It could also be because the instructor's better. There's confounds, there's other arguments that you could make of why that happened. That doesn't mean that it's not a valid finding. It simply means that I can't talk about causation. So when we manipulate the IV, we really can start to provide information about how the IV is impacting the DV, and we're eliminating potential other arguments of what's going on.